welcome back.
Hi.
Hi. So the last couple days, we were looking at graphs of linear functions. And we graphed them off of the table of values where we just had the ordered pairs and we just counted left and right and up and down and plotted points and then connected them with a line. And then the next day, we looked at the equation and we were graphing off of the equations. Well, what we want to look at today is the characteristics that these linear functions have in terms of the intercepts, where they're crossing different axes, their slope, range, and domain, whether it's increasing or decreasing, and then from the graph, being able to write an equation. Okay? So let's start with this one. Intercept. When I say intercept, what do you guys think?
Crossing the x-axis.
Yeah, where it's crossing something. I heard crossing an x-axis. I heard crossing a y-axis. Absolutely perfect. So the x-intercept is where the graph crosses the x-axis. There's the x-axis. Where does this thing cross? At -2. And so the x-intercept coordinate is -2, comma 0. I am going to be using a lot of colors today, so if you have them out, awesome. Where is the y-intercept? 0, comma 3. Notice how with the y-intercept, the x-coordinate is 0, and with the x-intercept, the y-coordinate is 0. What's the slope of this line? 3/2. We started at one point, we counted 1, 2, 3 up, we counted 1, 2 to the right. Our slope then is 3/2. What's domain? Do you remember? The x's. That's right, domain is the set of all x's. So if I look at my line, what are all the possible x values this thing could take? Could it take 1? Could x be 1? Yeah, and I'd still be able to graph it somewhere. All right, could x be 2?
Yeah.
What about 4?
Yes.
What about 1,000,000?
No. Or yes.
Yeah. What about -1,000,000?
No.
Yeah.
Yes, because these arrows mean we're going to continue on. And so our domain in interval notation is -infinity to +infinity. The domain is all of the numbers. All the real numbers. Have to be specific. What is range? The y's. And so what are all the possible y values? The same as the domain. This one is going to end up being all of the real numbers as well. Good. Now is this graph increasing or decreasing? Why? Yeah, because as you go to the right, you're going up, or its slope is positive. Good. Now we have to write the equation. Here's the thing, is the equation is really, really easy to write. Because if I write it in slope-intercept form, I already have the information. Here's the slope, here's the y-intercept, and so my equation is y equals 3/2 times x plus 3. Well, I wrote the wrong letter. I wrote b instead of 3.
Wait, Miss B is what? Line?
The y-intercept.
Oh.
It specifically is the y-coordinate of the y-axis. Easy enough? All right, let's do one more. I'll leave that visible so that we can see it. There it is. All right, now we're looking at this graph. Where's the x-intercept for this graph? -6, comma 0. Notice that with the x-intercept, the y-coordinate is 0. Where is the y-intercept? 0, -3? Okay. And then this is our y-intercept. What is the slope of this line?
-3/6.
-3/6,
Yeah.
or reducing it, 1 over 2. What's the domain? What are the possible x values this could take? All of the numbers, all the real numbers. Okay, so you could write it in interval notation, or you could write it as the set. So you can use the symbol for R for all the real numbers. What about the range? What's the range of this one? The same as the domain, all real numbers.
Why wouldn't it be like the same as infinity?
Yeah. So all real numbers is the same as writing that infinity to infinity.
Also the same.
Is this increasing or decreasing?
Decrease.
Decreasing. Negative slope. Very good. All right. What's the equation?
Negative 1.
Negative 1 over 2 x
Minus 3.
minus 3. Good. All right. We're good on that one?
Yeah.
Nice and simple, huh?
Yeah.
All right, so join me on the next one to the left. Give me just a moment, and I'll slide on over that way. Here it is. All right, what is the x-intercept?
0.
Yeah, it looks like 0, but it could also be here.
1.
Yeah, I think it's this one, 0, 1.
Yeah.
What about the y-intercept?
0.
Okay, this is 0, 1. The y-intercept is 0.
0, 1.
It looks like it's the same place, 0, 1. Oh, wait. Yeah, maybe 0, 0? Yeah. It's really hard to tell because it's kind of like right on top of itself. Yeah. So. What about the slope? So if I've got a crossing right here, there looks like there's another crossing right here. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 10. And then the x is only one piece. All right, what's the domain?
How did you do that?
How did I do what? Find the slope? So I started here, and I know that I wanted to get to this point. So I needed to get over to this line. So I moved over once. That's my x. And then from here I counted down. You say I miscounted, it should be 9?
Yes.
Okay, so let me count again. So then I count down, and as I'm going down, it's going to be negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You're right. I miscounted. Thank you. All right, what's the domain? Yeah, all real numbers. So if I write it interval notation, it looks like this. And the range? All real numbers again, and if I write it interval notation, it looks like that. Now what?
We could write it either way with the R.
You could write it either way, yes. Now if I'm specific, I say write this in set notation, then it needs to be the R. If I say write it in interval notation, it needs to be with the parentheses and the inner.
Well, why that point?
Why this point? Because it was easy to read, and for no other reason. All right, what's my equation? Y equals the slope of negative 9, x, and then our y-intercept. Okay.
Everything is decrease, right?
Hmm?
Decrease.
Yeah, this is a decreasing. All right, let's look at this one. What's the x-intercept? negative 4. Negative 4, comma, 0. What is the y-intercept?
Zero.
Where does it cross the y-axis? Nowhere. So this does not exist.
It's out.
Denny, does not exist. What's the slope? There is no slope. The slope is undefined because it's a vertical line. Undefined. It doesn't exist. What's the domain? What are all the possible x values this could take? It could take all of them?
One.
Oh, no,
Just one. Which one?
Negative 4.
So the domain is negative 4. And we're going to put it in set notation because we're listing all the possible x values that it could be, which is just the one. What's the range?
9.
A range is y values. What are all the possible y values?
Uh,
All of them.
Oh.
Because we've got those arrows that it's going through all of them. So my range, if I'm going to keep it in set notation, so that it matches the domain.
You said we can just put R, right?
Yeah, but since I put this with the set brackets around it, I should put this with the set brackets around it. Is this increasing, decreasing, or neither? Yeah, neither. All right, what's my equation?
X equals -4.
Yeah, x equals negative 4. Because regardless of what's happening with y, x is always going to be 4. When he gets back, I think I'll check him out. Yeah.
So if the y has like none of the points, you don't use it.
Exactly. All right, let's look at this one. Now we've got with the equation, we don't have the graph. Right? All right, so let's do the same thing here. What would be the x-intercept of this?
2.
Oh, wait, X.
The x-intercept happens wherever y equals 0. So if I take that equation and I set it equal to 0, and then figure out which x makes this happen, that is the x-intercept of this thing. So I'm going to subtract 5 from both sides. I'm going to divide both sides by 2. I did not write out the process that I was using. I just said what I was doing, and then I wrote the response. So make sure that you understand what I did and where, and make sure that I got the right numbers. I subtracted 5 from both sides, then I divided both sides by 2. Yes? All right, so my x-intercept then is going to be negative 5 over 2 comma 0. What is my y-intercept? 5, right here. 0 comma 5. Because with the x-intercept, y is 0, and with the y-intercept, x is 0. What's the slope?
2.
The slope is positive 2. It's this number right here. What's the domain?
R and R.
Yeah, all the real numbers. Because this is a linear function, so it's going to work just like all the others. What's the range? All real numbers again. Very nice. And we already have the equation written, so the last thing to ask yourself is increasing or decreasing? Increasing because we have that positive slope. Very nice. All right, let's look at this one. A little harder to tell because it's in standard form. So first step is let's convert it to slope-intercept. That way we can read our slope and our y-intercept and have a better idea of what's happening with everything else.
Subtract 15.
Yeah, I'm going to subtract 15 from both sides. 15x rather. And I'm gonna divide everything through by -3. I'm gonna write out that I'm doing that. And from here I can read my y-intercept. What would be my y-intercept? -10 is my y-intercept. So the coordinate is 0, -10. In order to get my x-intercept, what must I do?
Equals 0.
This equals 0. So I'm going to move 10 to both sides. So I have 5x equals 10. So 5x equals 10, x equals 2. And so my x-intercept is 2, 0. So far, so good? All right. What's my slope?
5.
There it is. My slope is 5. My domain? All the real numbers. I'm going to write this one in interval notation this time. And what's my range? Yes, indeed. Increasing or decreasing? Increasing. Very nice. Not too hard, huh? Good. We only have 2 left, so I'm going to scoot this over. This one's going to feel a lot like this other one. Do you want to see me do this or do you want to skip it? Skip it? Okay. So I'm going to scoot over to the last one. Do y'all want to see me do this one? Yeah, because it looks a little weird. The first thing you need to remember is that whenever you have this f of x thing, you can trade it out for a y. So this equation looks like y equals 5. If I were to graph this,
Well, it'd just be a straight line.
yeah, it would be a straight line and it would be somewhere here at 5. Okay, so our graph would look something like that. From this, what is the x-intercept? Does not exist. Very good. What about the y-intercept? 5. At 0, 5. What's the slope? 0. There is a slope. The slope is the y doesn't change. And so when the y doesn't change, the slope is 0. When the x doesn't change, then we can't talk about the slope. We have to say it's undefined. All right, what's my domain? All real numbers. What is my range?
5.
Just 5. Increasing or decreasing? Yeah, neither, because this thing is constant. Last question for you. Can a function that is increasing, okay, so this function looks like this, it's increasing. Can it have both its x and y intercepts be positive numbers at the same time? Okay, I've got difference of opinion. Those who are saying yes, how does that work? Those who are saying no, how does that work? Okay, like it goes in one quadrant? Yeah. So it's going toward quadrant 1, but we're actually interested in these locations. So in this example that I drew, they're not both positive. One is positive and one is negative.
It would be impossible
If I drew it over here to get this one positive,
to allow.
yeah, the y ends up way down here, and that's negative. So that doesn't work either. If I drew it here, does that work? Is 0 positive or negative? Yeah, neutral. It's neither. So that one doesn't work either. Ugh, so, is it possible? No. It says, if not, provide evidence. There's my evidence. That's all I had for you guys this morning.